Welcome to the single displacement reactions lesson. Okay, so again, I like to use the word or the word single displacement. You may have had a teacher in the past that has used single replacement. If you're watching videos online, they'll say single replacement. Sometimes they'll say single displacement. Okay, so in our past lesson, we looked and analyzed the different type of reactions that we're going to study in this unit. You should be at the point where, again, your nomenclature should be good to go now. You shouldn't be hesitating at all when you're naming formulas, writing them out, reading them. And you should be able to balance equations now, and you should be able to identify um, when you see a chemical reaction equation, what kind of reaction it is. Okay, so today we are going to specifically study single displacement reactions. Okay, so again, what we were trying to look for was that an element was coming in. It could be a metal, it could be a non-metal. It was coming in and it was displacing another element that was similar. So if it was a metal, it will just displace a metal. If it was a non-metal, it will displace a non-metal. Okay. So you're going to see the element come in, interact with the compound, react with it, and then the element will combine with part of that compound, and then an element will leave. Okay, so you'll see an element coming out as one of the products. So if you see an element as a product, then you have a single displacement reaction. So an element comes in, swaps places, and then an element gets kicked out. You have your single displacement reaction. Okay, so here in these visual diagrams here, I'm just showing you that A is a metal, comes in, B is the other metal, boots out B, and then makes a compound with X. You can also have a scenario where Y is a nonmetal, and so the nonmetal always comes second in the formula. So the green here is the nonmetal, so the Y is going to come in and displace the green nonmetal out and combine with the metal, which is the red here, make a compound, and then the nonmetal X is out. Okay, so that's if a reaction does occur. So just keep in mind that sometimes you're going to learn today, a single displacement reaction doesn't always occur. So if a metal comes in, doesn't mean it's always going to react. Okay, so if a non-metal comes in, again, doesn't necessarily guarantee that it'll have a reaction. So we're going to look at when there is a reaction, when there isn't one. Okay, so I've already discussed how you can have a metal that comes in, or you can have a non-metal that comes in. But the main thing is metal displaces a metal, a non-metal displaces a non-metal. We're going to also see hydrogen being displaced. Hydrogen is that one, it's always kind of its own little group. It's not a metal, but it acts like a metal, and it has kind of properties of both. So in this case here, for this lesson, we're going to treat hydrogen like a metal, okay? So we're going to see hydrogen, it's going to be in an acid or in a water, and we're going to see the displacement there. Okay, so this is what's new for this year, the activity series. So I'm going to introduce this to you, and then I'm going to show you how to use it. And then it's going to help us predict whether a reaction will occur and or when it won't occur. Okay, so we have this one here. This is actually on the back of your formula sheet. If you can click to the formula sheet. So this is on the back of your periodic table here. It's not like when I photocopied it, it's just black and white, but if you wanted to go and highlight it, the ones with like the longer dashes here, and it says reacts with water. Okay, so I'm going to keep referring to that as, I don't know, the blue water square. And then there's these ones with the little dashes here. It's the red box, and it's kind of the acid box, okay? So just have your formula sheet, which should be on the back of your periodic table sheet. That's in that little plastic cover. Just have that out so that you can keep referring to it. But this is actually on the note as well, so that helps. Okay, so this is the metal reactivity series, and on the side here, this is the halogen activity series. So it's not on your formula sheet that we just looked at here, okay? But if you look at the periodic table, so here's part of your periodic table. So if you look at the periodic table here, so you see the halogens are right here. So basically that's where the halogen activity series is. So if you just see fluorine, it's above chlorine, it's above bromine, it's above iodine. So I don't have that on your formula sheet. So this here, because that's all it is. It's just pretty much when you see a halogen coming in trying to react, whether if you're trying to determine if they're going to react or not, you're just going to look at the halogens on your periodic table here, and it's just the same order here, okay? All right, so now that you see the activity series for the halogens and the metals, I'm going to show you how to use them. Okay, so again, we're just studying single displacement reactions here. An element's going to come in, and we're going to determine whether this reaction is going to occur. So here's the first example here. We have copper. It's coming in, and it's being placed into a solution of silver nitrate. So basically, we're going to write out the chemical equation here and decide with the activity series whether the reaction will occur. Okay, so let's start with writing the formulas out. Okay, so again, you just have copper metal. So whenever you just have a metal, you just write copper. Okay, I know some people get confused because they know copper can take a 2+ charge, a 1+ charge, so they want to write the subscript like 2 all of a sudden. Okay, don't do that. So the metals, just write the metal. Okay, there's no subscript. Okay, so from there, you are writing this one here, silver nitrate. Okay, so again, if you're still a little bit shaky with nomenclature, feel free to just kind of do some work around it. So I know silver here, if you're looking at your periodic table, you're like, okay, silver always has a 1+ charge. Okay, and nitrate. Okay, so again, when you're like, where is that? Flip over to your polyatomic table. Okay, so nitrate, okay, is NO3 -1. Okay, so if you combine those, one silver needs one nitrate to make a compound, or some of you like the crisscross method, you can use that as well. So in the end, you have silver nitrate. Okay, there's been some questions about, what state symbol should I be using and so forth. I just introduced it to you in some earlier lessons, but for now, don't stress about the state symbols. I'll show you how to do those in a bit. Okay, so for now, we have copper metal coming in, and it's being placed into a solution, so an aqueous solution of silver nitrate. So we need to determine if this reaction is going to occur. So since the metal is actually coming in here, we're going to go look at the metal activity series here. Okay, so these are all the metals. So I want you to go and find copper, and then look for the metal, because copper is going to try to take out silver. So let's see here. Here is copper right there. Okay, and then silver is underneath. Okay, so I always teach the activity series as kind of like an analogy, is like kind of a, I don't know, it's like a battle event. Okay, so if you are higher up on this list, you are considered to be the stronger opponent. Okay, so if you're higher up on the activity series, you have the ability to displace anyone that's lower than you. Okay, so the higher you are, the more power you have. You can think of it that way. And so you have the ability to displace any of the metals underneath. So in this case here, since copper is higher, we're going to displace the silver. So this reaction will occur. So again, here we go. And then, so copper is going to combine with nitrate. And right now you're probably thinking, okay, what charge is it? So you need to go to your periodic table. Okay, so if you take a look here, here is copper. So if you look carefully at the valence, so the valence is in this corner here, those are the charges. So copper can take a 1 plus charge or a 2 plus charge. So if you see, so like there's this note, bold is most stable. So I want you to grab the one that's bolded, so the 2 plus. It just means that it's more stable. It's more likely to make a compound here. So so if you go here, so you're gonna, again, if you're trying to do your work on the side, it's, you have a copper 2 is trying to combine with the nitrate. Okay, so you're gonna need 2 nitrates for every copper. Okay, or if you crisscross them, the 2 comes down, the 1 goes over there. So now you get a copper nitrate compound. Okay, and then what happens to the silver? It gets booted out. Okay, it gets displaced. That's why it's called a single displacement reaction. Okay, one thing I do want to note here though, if so what I just showed you here with the copper 2, so we just took the one that was most stable and made a compound. We actually don't know which copper, it could be that the other one does form. We don't know which one does form. We do need to, run some more tests and analyze it that way, and then we know exactly what copper would have formed. So if you decided that, if you went and took the copper, plus 1 charge, okay, and combined it with nitrate and then made, so if I do that underneath, if you did this, so it's 1 copper needs 1 nitrate, so if this 1 bugs you, you can just change it to a plus. Okay, so 1 copper to 1 nitrate. So if you did this and made this compound, so copper 1 nitrate versus the copper 2 nitrate, and then wrote that the silver got displaced, I will accept that as an answer as well. So both of them are fine. In the end, like, you can't determine exactly what copper it was. You have to run some other tests. So both are acceptable. But again, if you just wanted to have a way of just doing it one way, just take the one that's more stable. So the one that's bold on the periodic table. Okay. All right, so that reaction occurred. So again, if you wanted to practice and balance it out, you can do that as well. If you're getting a hang of doing state symbols, you can do that as well. So any of the metals will be solids. Okay, these solutions here, these compounds generally are aqueous, and then here the silver would come out as a solid as well. All right, let's move on to the next one. So we have our a piece of silver metal is placed into a solution of copper 2 nitrate. Okay, so let's write that out. Okay, so copper 2 nitrate. So again, if you want to show your work here, copper 2 NO3, okay, and then you end up with that compound there. All right, so I'm just going to go to our activity series here, and I'm going to erase these other arrows that I wrote in. So you go into your activity series now, and then again you're analyzing, okay, where silver is trying to come in here now, and copper is the other metal. We're going to analyze and see if this reaction will occur. Okay, so again, here's copper, here's silver. Okay, so in this case here, silver is the one. Silver is the one that wants to come in and displace. Silver is the one that wants to come in and displace the copper. Okay, so since silver is lower, okay, it is less reactive and therefore cannot come in and displace the copper. Okay, so in this case here, if you see that it's lower, then you would write no reaction. Okay, so think of it kind of like a battle. So in the example 1, copper came in and tried to boot out silver. Copper's higher up, has more power, more reactivity, so it can boot out the silver and combine with nitrate and make a copper nitrate compound. For example 2, silver tries to come in and boot out copper. Can't do that copper's higher, okay? So copper's going to hold on to the nitrate, silver is not going to work here, so you get no reaction. Okay, so let's move on to the next example here. Okay, so example 3. So Colin's trying to make some thermite here, and he takes aluminum and iron 3 oxide. Okay, so let's see if this is going to happen if he takes these reactants here. Okay, so we have aluminum. Okay, so just aluminum. Remember, if it's just the metal, just write the element aluminum. Okay, no subscript. Okay, and then it's iron 3 oxide. Okay, so again, you're like iron 3. Okay, the Roman numeral tells you what charge for iron. And then oxide. Oxygen has a -2 charge, so we need to make a compound here of 2, 3. Okay, so you need 3 oxygens to 2 irons to make a compound here. Okay. All right, so iron 3 oxide, we're trying to determine here if this reaction is going to happen. So let's take a look at the activity series. I'm going to erase these other arrows out of here. And, okay, let's go find aluminum. All right, there's aluminum right there. Okay, and iron is right here. Okay, so who's trying to come in and displace? Aluminum is coming in. Okay, so since aluminum is coming in and it is higher, it is more reactive, it's going to get this done. Okay, so we are going to have a reaction here, so let's get the single displacement to happen. So again, if you want to just, kind of show your work, or just kind of do your work over here on the side. So you're like, okay, aluminum is going to displace iron, so aluminum has a 3+ charge, and it needs to combine to make with oxygen. So the new compound here will be like that. Okay, 2 aluminums to 3 oxygens, and then iron gets to hit the road. Okay, gets chucked out of there, gets displaced. So this is why I've been drilling that you guys have to get your nomenclature down, because if you are still trying to figure out how do I make a compound with aluminum and oxygen together and this is still slowing it down, it's going to take you forever to learn this, okay, and get through this material. So again, please make sure you work the nomenclature until you're awesome at it, okay? It's going to slow you down. It's going to cause a lot of headaches otherwise. So, okay, so we know that this reaction occurred. Aluminum was higher, okay? So this one note here at the bottom. So keep in mind if you were reacting these reactions together. So for example, example 1, copper and silver. Copper and silver were here. Okay, copper came in and did displace silver. So basically, if you were watching this reaction, it would be quite slow compared to this aluminum and iron here, okay? Because the further apart you are, okay, the faster the reaction will occur. So if you think about it as like, if you have copper and silver here, they're tied. They're really close together on the activity series. So basically, copper is higher, so it's a little bit, it's a bit more reactive, so the reaction's going to happen, okay? But it's just that reaction's going to take a lot longer. It's going to take its time because think of it as not having as much power. But then if you look at the aluminum iron, there's some space between them, okay? So if those elements are further apart, the reaction is going to be a lot faster. So if you had like lithium and copper, that reaction is going to be even faster. Okay, so the rule of thumb here is the further apart the two elements are on the activity series. Okay, even if it's the halogen series here, the quicker the displacement reaction will occur. Okay, so all right, let's move on to the next part here. Okay, so that was a metal displacing another metal. Okay, so let's move on to a non-metal displacing or trying to displace a non-metal. Okay, all right, again, I'm just putting a note here. The halogen activity series will not be provided on assessments. Okay, remember, you just go to your, like when you have to figure that out, you just go to your periodic table and go, oh, okay, fluorine's the highest, then chlorine, then bromine. Okay, so fluorine is the most reactive. Okay, so it'll displace everyone underneath. Okay, so you have iodine here, can displace whatever's underneath, but it cannot displace the stuff above it. All right, so let's go through and try these out. Okay, so on top of it, when you have these halogens coming in, keep in mind when you're making the formula that these halogens are diatomic. Okay, so when you're writing the formula out. So example 4 here, we have chlorine gas, so Cl2, okay, is bubbled through an aqueous solution of sodium bromide. Okay, so again, if you wanted to do the work up here before you write your formula, and you're like sodium is a charge of 1, bromine is a charge of 1, all right, so you need, it's a 1-to-1 ratio, okay, or if you crisscross, that's what you get there. Okay, and then we have to decide, is this reaction going to happen? Okay, so let's take a look at our activity series here on the side. Okay, so we have chlorine is here, bromine is here. Okay, so again, chlorine is higher. It's trying to come in and boot out bromine. This is going to happen because chlorine is more reactive. It's higher up on the activity series. So again, so if you want to write your work on the side, so chlorine, you know, it's a -1 charge. It's going to break this ionic compound up, okay, and grab the sodium here. So then you have sodium, okay, is 1+ charge, so you know it's an NaCl formula, and then bromine gets booted out. And remember, all the halogens are always diatomic, so it should be Br2. Okay, so like up here, when the metal got booted out, there was no subscript, right? Because the metals don't have the subscript. You just write the metal element. Okay, but the halogens, they're diatomic, so you come in as a diatomic, come in and react with sodium bromide, okay, becomes sodium chloride now, and then bromine gets booted out, and it's a diatomic. Okay. Okay, so let's just move on to example 5. So it says here, predict if the reaction will occur. If so, write the products. Otherwise, make sure if it doesn't, if the reaction doesn't occur, you have to write no reaction. You have to show me that so I can give you the mark. Okay. All right. So we have iodine here. It's coming in, and it's trying to react with sodium chloride, and we're trying to see if iodine can displace the chlorine. So again, let's look at our halogen activity series here. Okay, just erase these out of here. So we have iodine, which is here, and it's trying to take out chlorine. Okay, so iodine is lower on the halogen activity series, so it will not be able to displace the chlorine out of sodium chloride, so there will be no reaction. Okay, the sodium and chlorine will stay together. Okay, all right, so that's how you use the halogen activity series. Okay, so we've looked at metals displacing metals, nonmetals displacing nonmetals. Okay, and now we're going to start looking at why is there a blue little box here and a red box. Okay, so we have to pay attention to where the, so now we're just looking at the metals reacting here. We have to pay attention to where those metals are on this activity series, and when they react with water, and when they react with acids. Okay, so again, what's happening here is the metal's going to come in and react with the H in water, okay, and displace it, or it's going to come in and react with the H in the acids. Okay, so acids always start with H. But if it's not within this box, then you're not going to get a reaction. All right, so let's kind of go through some examples here. So, so this section is called the metals displacing hydrogen from acids or water. Okay, so like I said already before, hydrogen is not a metal, but it behaves like one. So what we're gonna so when it's an ion, it's an H plus +1 charge, and we're gonna go through and start with just reactions with water. Okay, so if the metal is inside the blue box here, So if we're looking at the metal and we're looking to see where the hydrogen is, so I'm just going to show you hydrogen's way down here. Okay, so we're looking at all the metals above it, and we're going to see if the metal can displace the hydrogen and so forth. Okay, so if you are in the blue box here, so lithium, potassium, barium, strontium, calcium, sodium. So again, keep in mind this is the activity series that we're using here in Chem 11. If you go on and keep studying chemistry, the activity series does have a lot more elements in it, and but you can still use it the same way. We're just putting some metals here together that we're going to use to study the reactivity and the reactions and so forth. But it's kind of like a smaller version of what is out there, though. Okay. Okay, so the metal in the blue box will replace the hydrogen. Okay, and what's going to happen is you're going to end up producing hydrogen gas, which is the H2 diatomic gas. Okay. Water is not a ionic compound. We know we've already studied it. It's a covalent compound. The atoms come together and they share the electrons, but we're going to treat it like an ionic compound so that it helps us with forming the new formulas, okay, for the products. All right, so let's start with the first one. We have sodium, okay, example here, sodium and water, okay. So look for sodium. Here it is, okay. It's in the activity series. It is above hydrogen, so you're like, okay, it's going to work, right? But you got to make sure it's inside of the water box. So if it's inside the water box, this reaction will happen. Okay, so again, think of water as being like H plus and OH minus. So what's going to happen is that sodium is going to come in, grab onto the negative ion here. Okay, so if you want, you could think of it as sodium and hydroxide. So they're going to combine and make a compound. So what does it look like? Sodium hydroxide, like that. Okay, 1 to 1. All right, so sodium's going to come in and it knocks out the hydrogen and grabs onto the OH and makes sodium hydroxide. And then what's left is hydrogen gets booted out, and hydrogen's a diatomic. So write it as H2. So sodium comes in, displaces the hydrogen, and creates hydrogen gas, okay, with sodium hydroxide like that. All right. So I didn't put an example here, but we can add one in right now. Let's do this one. So what if we grab a metal like aluminum? Okay, so aluminum is right here. So what if we get aluminum and dump it into water, and is this reaction going to occur? So see how aluminum is not, if you're looking here, aluminum is not inside the water box, the blue water box here. Okay, so I know that aluminum is higher than hydrogen, so you're like, oh yeah, I should be able to take out hydrogen, knock it out of there. But since it's not in the water box, then it will not react. So you have to write no reaction. Okay, so again, sodium worked. It was in the water box. It is higher than hydrogen, so it displaces it. But if you a metal that is not in the water box comes in and tries to knock it out, it's not going to work. Okay, the same thing applies if anything is below hydrogen down here. So like silver, mercury, these are all not in the water box, but on top of it, they're lower than hydrogen, so they're not going to come in and knock out the hydrogen. Okay, so aluminum here, no reaction, like iron, cadmium, all of these will be no reaction. Okay, so hopefully you feel confident with how the water box works here on the activity series. Okay, so again, if you are in here, you can displace the hydrogen out of water and make a new compound and produce hydrogen gas. Okay, so let's move on to the red box here now. So this is the acid box. So the metal is going to come in here and displace the hydrogen. So if you are in this red box here, you can displace the hydrogen out of an acid. Okay, so it's the acid box. So again, treat the acids like, so again, the acids are, treat them like they're ionic. So the hydrogen, hydrochloric acid becomes H plus Cl minus. And then the like sulfuric acid here, okay, H plus and SO4 2 minus. Again, if you do that, it's a lot easier to combine them and make a new compound. Okay. Okay, so let's look at lithium coming in and reacting with sulfuric acid here. Okay, so we have lithium with an acid. Okay, so it's either acid or water. Okay, so it's an acid. We're going to see if this reaction is going to occur. So let's take a look at where lithium is. Okay, so we see lithium here at the top. Okay, and we're looking to see if it can displace hydrogen out of sulfuric acid here. So lithium is in the acid box, so yes, this reaction will occur. Okay, so again, so if you want to do this on the side, lithium, you know, has a 1+ charge. It's going to combine with sulfate, which has a -2 charge. So you're going to get a compound of lithium sulfate, okay, and it boots out the hydrogen. Okay, so lithium can react with this acid and displace the hydrogen and create a lithium sulfate compound. Okay, all right, let's try the next one, magnesium and hydrochloric acid. Okay, so again, we have magnesium coming in, hydrochloric acid. Okay, is this reaction going to occur? So take a look at the activity series here. Where's magnesium? There it is. Okay, it is still within the acid box, so this reaction is going to occur. So again, aside here, magnesium is a 2+ charge. It has to combine with chlorine, which is the negative charge. So you're going to get magnesium chloride like that, and the hydrogen gets booted out. Okay. And let's add one to the examples here. So I'll get you to try this one here. So what do you guys think about silver coming in to try to boot out, I don't know, sulfuric acid? Okay, all right, so take a look at the activity series here, and you're like, silver, there it is, okay? It's not in the acid box, you know, on top of it, it's lower than hydrogen. It's not going to happen here, okay? So in this case here, you would write no reaction. Okay, all right, so there is the single displacement lesson for today, okay? So if you take a look here, just an overview. So again, you learned last year pretty much how to identify a single displacement reaction, given clues. If an element came in, now out the other element, then you were like, you just labeled it as a single displacement reaction, okay? So the new stuff this year is that these reactions sometimes don't occur. So it is dependent on the metal activity series and the non-metal activity series, or the halogen activity series. So make sure that, again, you know that this is just like the periodic table here, okay? And this will be provided to you during assessments, so you don't have to memorize it. You just need to know how to use it, okay? So again, the top box here, since you guys have it in black and white, the top box here is the water, and it says reacts with water to remind you. The next bigger box here is the acid box, okay? All right, so if a metal comes in, remember, if you're higher, you can displace something that's lower, okay? If you're not higher, no reaction is going to occur. And if you are further apart, okay, the greater the distance here, I guess, in the activity series, the faster the reaction is going to occur. where if it's nice and close like that, it's almost like you're tied in the amount of power that you have, so it's going to take a little longer, but the reaction will occur. If copper tries to displace silver, it's just going to take longer, where if you're lithium and nickel, okay, that's a big distance there, so that reaction is going to occur a lot faster. And non-metal. So again, you're going to use the halogen activity series to determine if a reaction occurs or not. So again, you need to be able to write out the products. Okay, so that's where this nomenclature skill comes in. So make sure you can do that. All right, and the last bit here, yes, the water and the acids. Okay, so if you're a metal inside of the water box, you will be able to displace the hydrogen out of the water. Okay, and so you're producing hydrogen gas. If you're a metal inside of the red box here, you will displace the hydrogen out of the acids. Okay, and make a compound. But if you're not in those boxes there, then no reaction occurs. So like aluminum here was not in the water box, so no reaction. Silver here, not in the acid box, no reaction. Okay, all right, so just go and do some practice questions. Again, check your answers, make sure you're good to go, and then try the checkpoint. Okay, thanks for watching.